Alright, so let's take a look at this. You can see it says example 5. I've done uh, 3 other videos. The first video has examples 1 and 2, the second video has example 3, and the third one has example 4. So, you may want to check those out. They're a little bit different. They have trig and functions, e to the power, and natural log functions, and all that. Alright, so in the first video, it's the basic ones, your more common, like just x's and y's in there. Alright, but let's look at this one. Let's take the partial of z with respect to x. Alright, so let's see. We've got the partial of z with respect to x. So remember, x is your variable, y is treated as a constant term. We treat y as a number. Well, here you can see we have the chain rule. So the chain rule, I'm going to bring the 4 down and subtract 1 from the exponent. Okay, remember you bring the exponent down and subtract 1, and then it's times the derivative of what's inside the parentheses. Okay, so the derivative of this in here, well, the derivative of x squared is 2x, and then I have the derivative of xy cubed. Now remember, y cubed in this problem, finding the partial of z with respect to x, the y cubed is a constant. So we have xy cubed. Okay, well, let me ask you this. What's the derivative of 5x? It's 5. What's the derivative of 7x? It's 7. That's the same thing here. This y cubed, that's like that 5. So what's the derivative of xy cubed? It's just y cubed. Okay. All right, well, and that's it. That's your answer right there. Okay. I mean, that's pretty easy. And don't look like there's much you can do with it, so we can just leave it like that. I guess if you want to, you could distribute the 4 to each one, but that's no big deal. All right, so let's do it the other way. The partial of z with respect to y. This one's actually a pretty easy one, isn't it? The second and third videos are the tougher problems. All right, so let's find the partial of z with respect to y. Use chain rule, so the 4 comes down, and that's x squared plus xy cubed, and subtract 1 from the exponent. Okay, times the derivative of what's inside the parentheses. So I've got to take the derivative of x squared plus xy cubed. Well, what's the derivative of x squared? Remember, x is a constant because we're taking the partial with respect to y. X is a constant, so the derivative of x squared is 0. Now let's take the derivative of this, xy cubed. Okay, well, the 3 comes down to multiply to the x, so that's what? 2xy, and subtract 1. So it's 2xy squared. So this is times 2xy squared. Remember, x is a constant. That would be the same thing if we had 5y cubed and we were taking the derivative of this with respect to y. Well, the 3 comes down. What's 3 times 5? 15y squared. Same thing. That's all we did here. Well, I'm sorry. Look at what I did. That should be a 3. Bring the 3 down. 3 times x is 3x. Got a little ahead of myself there, I guess. Okay, so we get 3xy squared. All right. All right, so now, well, we can do a little with this. We can multiply the 4 to this. So 12xy squared times x squared plus xy cubed, all that raised to the third. All right, so this will be my last video on partial derivatives for a little while anyway. I might later on do some more, maybe try to make them tougher than this. But hopefully these help, the 4 that I made. But subscribe to my channel and you'll see if I post any more later. Uh, Hopefully it helped. Don't forget to like and subscribe. Check out my other videos. All right, thanks.